Hi everyone, today we're going to talk about section 12.2, conditional probability. A student committee is being formed to decide how after-school activities will be funded. The committee members are selected at random from current club members. The frequency table shows the current club membership. Data. What is the probability that a member of the art club selected at random is a junior? Okay. So we have this table here. We've got sophomores, juniors, seniors. The totals are at the bottom, and it's split up into number of students in the drama club, in the science club, and then in the art club. Okay, and then you've got total of each grade level across the top. So for example, that means there are 40 members in the science club, 58 members in the art club, etc. Okay. Now, they're asking us, what is the probability that a member of the art club, notice these are in color here, is a junior. So juniors are also in color. So we call this conditional probability. Notice there are two things that we're looking for. We're looking for a member of the art club and the fact that they're a junior. Okay, so the probability that an event B will occur, given that another event A has already occurred, is called conditional probability. Okay, so basically it's saying the probability of B if A has already happened. That's sometimes how I read this. You kind of go in order. The probability of B happening if A already happened, okay? So in this case, we're talking about, so it's saying what is the probability that a member of the art club selected is a junior, okay? So we're saying the probability that it's a junior if it's a member of the art club, okay? So it says use the frequency table to find the probability that the student selected is a junior given that the student is a member of the art club, okay, which is why we put it in this order, because that's what we're looking for, is that given that they're in the art club, what's the probability they're a junior, okay? So what we want to look for is the total number of juniors in the art club, and there are two different ways that we can go about this. So this is the first method. This method works if you have the frequency table. If you have a table that's handy, it's got all the data in front of you. A lot of times this is the easier method. So we would see the total number of juniors in the art club. So if you're looking at the total number of juniors in the art club is right over here. We've got 16 juniors, okay? And the total number of art club members is 58, okay? Now, this would be our probability because we're just looking for art club and we're just looking at the juniors, okay? Now, if I were to reduce this fraction, I've showed you guys how to do this before. Okay, you have a percentage decimal, that's fine. If you hit math, frac, you end up with the reduced fraction of 8 over 29, okay, which is what we have right over here. Now, you're not always going to be given a data table like this where you've got all the information handy, or maybe you're just looking for a different way to do this. And for us to do that, there's a formula for conditional probability. And it's right over here. Okay. So conditional probability formula says you're going to find the probability of B and A occurring at the same time. Okay. And you divide it by the probability of A. Remember, A is the, if we're doing over here, I should do that. A is the given event. Okay, so in this case, we're talking about the fact that the student's a member of the art club. So given that they're a member of the art club, what's the probability that they're also a junior? So the way that we would set this up, so notice it's the probability of being a junior given that they're in the art club. Well, you would have the probability of junior and art up top divided by just the probability of art. So the probability of the second portion over here. So we're going to look back up at our table. So the probability that they're a junior and in art would be this box over here, 16 out of the total number of students, which is 115. So that's up top. The number of art students is 58 out of the 115. And the 115s are going to cancel here in this case. And we again end up with 16 over 58, which reduces to 8 over 29. Obviously, we got the same probability because we were looking for the same thing. They were just two different methods. Okay, so let's take a look at this next one and say, what's the probability of that a member of the drama club is a sophomore? Okay, so similar type of setup. We're going to do the probability that it's a sophomore given that they're a member of the drama club. Okay, now just for the sake of using our new formula here, I'm going to use this instead of the quicker way that we did in method 1. So I'm going to do the probability of soph and drama divided by the probability of drama. Okay, so looking at our table, numbers of the probability of a sophomore and in drama, looking at our table, sophomore and in drama would be here, 3 out of 115. Not a lot. Divided by just the number of drama students. Total number of drama students is going to be 17 out of 115. Okay, now again, I showed you guys that when the denominators are the same, they cancel, but I can show you in the calculator too. If you wanted to type this in, you would need parentheses around the fractions. Okay, so I've got 3 over 115 divided by 17 over 115. Okay, so I just typed this whole thing into my calculator. Math, frac, and we end up with 3 over 17. Okay, again, if we had just canceled those out, that's a little bit faster. You get 3 over 17. Okay, now what if we switch this around? What if we have the probability that a sophomore is a member of the drama club? So we're saying, okay, we're saying given that it's a sophomore, okay? The given portion is always going to be the second part of our notation. So we know that it's going to be the probability of drama given that it's a sophomore. Okay, well, the key in the numerator, remember, is the probability of drama and soph. But we're going to divide by the probability that it's a sophomore. Okay, so the probability of sophomore and drama, we already found that. That was 3 over 115. But what about the probability of a sophomore? Sophomores over here. We've got a total number of 36 out of 115. Because we're looking at the totals here. So we end up with 3 over 36, which reduces to 1 over 12. So notice that we had a different probability if we flipped around our givens. If we were given that it was a sophomore in this case, rather than given that it was a drama student. Okay. All right, so let's jump to the next page. So this little section just summarizes what we just talked about. And it also talks about independent events, which we will clarify right now. So if events A and B are independent, remember that means that independent means one does not affect the other. Okay. Then the conditional probability of B given A equals the probability of B given the conditional, oh, just read that wrong. Then the conditional probability of B given A equals the probability of B, and the conditional probability of A given B equals the probability of A. That's very wordy, and it's easier to explain over here. So for this first part, we're saying, okay, probability of B given that A happens is just the same as the probability of B. That means A doesn't affect anything, okay? So the given doesn't affect B, okay? So the probability of B happening, given that A happened, is the same as the probability of just B because A didn't have an impact. Likewise over here, the probability of A given B, well, B doesn't have any impact, so it's just the same as the probability of A, okay? So the given doesn't affect B, or the probability. Okay, and the converse is also true, which is basically saying that if this is the case, if you have the probability, the conditional probability equal to the probability of the first event, then they have to be independent. Okay, so basically, in order for us to determine if we have a dependent or independent situation, we need to find the individual probabilities and also the conditional probabilities. Okay, so example 3 says the table below shows the vehicles in a parking garage one afternoon. A vehicle from the garage will be selected at random. Let B represent the vehicle is black, okay, and V represent the vehicle is a van. Are the events B and V independent? Okay, so what we want to look for is the conditional probability here. Okay, so let's find the probability of, let's find the probability of, let's see, that it's a black, actually one sec here. Okay, let's find, the probability of the vehicle being black. Okay, so if we look at the total number of black cars, we've got 13 out of 22. Okay, and our other situation is that the probability is that the vehicle is a van. Okay, so we want to find the probability that it's a van given that it's black. Okay, so we're going to use our conditional probability from the previous page and say that what we want is the probability that it's a van and black over the probability that it's black. That was the point of us finding this, okay? So let's take a look. So we want van and black. Let's see, well, how many black vans do we have? There are 3 out of 22 cars. So we're going to have 3 over 22 over the probability of it being a black car, which is 13 over 22. Okay, which leaves us with 3 over 13. Okay, so what we're looking for is that, going back up to our stuff up here, if the events are independent. That means that the probability of A given that B happens would have to be the same as if we had the probability of A on its own, okay? Well, let's see here, okay? We've got the probability of V given that B happens. Is it the same as the probability of just the van is what we're looking for. So the probability of just a van is 3 out of 22. Because we have 3 vans out of 22 total. So are these two the same? Notice they are not the same value, so we're going to say no. There's a different color here. Okay. Reason being, these two are not the same probability. Okay. So what you're looking for is the conditional probability and then the probability of just the first part on their own being the same. Okay. All right, so let's see here. Let R represent the vehicle as red and C represent the vehicle as a car. Are they independent or dependent? So let's see. If we do the probability, red given car, and then we also have to find the probability of red, probability of the first part. So these are the two things that we're looking for, okay? So our conditional probability formula means we want the probability of red and car over the probability of the car. This is our conditional probability formula. Probability of both over the probability of the given, okay? So looking at our chart, red cars, how many are there? We've got 5 out of the total. So 5 over 22 cars total. Probability of just a car is 11 out of 22. Okay, so we end up with, moving over here, 5 over 11. Okay, fine. All right, so what about the probability of just the red car? Or just the fact that the vehicle is red. So the probability of a red vehicle is, let's say, 7 out of 22. Okay, now are these the same? We've got 5 out of 11, 7 out of 22. Again, we have a situation where no, okay, they're not the same. So that means if they're not the same, actually we forgot to answer that here, that they are dependent. Okay. Okay. Not the same. Okay. If you did get the same probability, that means they would be independent of each other. Okay. All right. So let's move on to our last page and see some additional problems. Okay, so a band's marketing agent conducted a survey to determine how many high school fans the band has. What is the probability that a surveyed student plans to attend the band's concert and is a fan of the group? So we want to use our conditional probability formula to find our combined probability. So what is the probability that the student, surveyed student, plans to attend the band's concert and is a fan of the group? Okay, so both of these things are what we're looking for. So we want, let's call these events. Let's say planning to attend is A and being a fan of the group is B, okay? So we need to figure out the probability of being a fan of the group and that they plan to attend, okay? Because planning to attend probably depends on this happening. So, all right, so being a fan of the group. Excuse me. All right, so the probability of the fact that they're a fan of the group, given that they're planning to attend the concert. So what this looks like is our conditional probability formula. It's the probability of B and A divided by the probability of just the given, which was A. Okay. All right. So if we have this formula here, let's take a look at our information. So students who plan to attend, 70% of students plan to attend, 80% of students who plan to attend are fans of the band. And of students who don't plan to attend, 30% do not plan to attend, and 25% are fans of the band. Okay, I'm just gonna hit the pause button for 1 second. Okay, so now looking at our setup here, if we're thinking about what we're trying to solve, we're trying to figure out what's the probability that a surveyed student plans to attend and is a fan of the group. So really what we're looking for is this portion. We don't know that. Okay, see that and? It's the same and as we have over here. Now, do we know these other two pieces? The probability that it's a fan of the group, okay, given that they're attending the concert. Well, if you look at this table, students who plan to attend the concert, well, we have that information. 80% of the students who plan to attend are fans of the band. So if we say here, the probability that they're a fan of the group, given that they're attending the concert, it's these people. Okay, so we've got 80%, 0.8, on this side. Now, I still don't know the probability of B and A. That's what we're looking for. Okay, but I do know the probability of attending the concert. Okay, so it says here 70% of students plan to attend the concert. That's 0.7. Okay, so if I were to just try to solve for the probability of B and A, it's just a matter of multiplying by both sides, just getting that probability by itself. Okay, so typing this into my calculator, I get the probability of B and A as being 0.56. Okay, so that's a 56% probability. Okay, that they plan to attend the concert and that they're a fan of the group. Okay. All right. What is the probability that the surveyed students, or that a surveyed student plans to attend but is not a fan of the group? Okay, so let's see what happens here. So if we've got plans to attend and not a fan of the group. Okay, so if we think about what we did over here, it was, let's say, 70% plan to attend. Okay. Okay, so we've got 70% of students plan to attend. Now, if 80% of students who plan to attend are fans, that means that 20% of students who plan to attend are not fans. Okay, remember the total percentage has to be 100. So if 80% are fans, 20% are not fans, as long as they're all planning to attend. Okay, we're still talking about the same group. So we're going to multiply that by 0.2, which is our 20%. So that gives us 0.14 as our probability. Okay, kind of using a similar setup as what we had here. So we have 14% plan to attend but are not a fan of the group. Okay. All right, so we've got a couple more problems over here. I'm going to go ahead and hit pause and have you guys give them a try on your own. They are somewhat separate from each other, so go ahead and give them a try, and I will work through them in a moment. All right, so looking at this first example, a marketer is looking at mobile phone statistics to help plan an online advertising campaign. She wants to find out which of her company's products is most likely to be purchased after a search for that product on a mobile phone. Okay, so we're talking about purchased. Okay, given that they've searched. Okay, so a purchase would be considered this column here. So search and buy. So the probability of, let's say buying, given that a search has happened. Oops, in parentheses. Okay, given that we're buying, given that a search has occurred. Okay, so if we think about our conditional probability, it's the probability of buying and searching over the probability of just searching. Now, lucky for us, if you guys look at this table, we have the probabilities. See how they're all percentages? The probability of searching and buying is in this column, and the probability of just searching is over here. So really what we would need to do, so let's say for the probability of W, actually we'll just do this, we'll make a little chart. Okay, for W, it's going to be 16% S and B divided by 46%. So it's 0.16 divided by 0.46. We're just going to divide those. Okay, and let's extend that out a little. All right, so putting this into my calculator, I get 0.347. Okay, actually let's round to the nearest. 34.8%. Okay, so for all these, we're just going to divide because I have the probability for the numerator and I have the probability for the denominator. Okay, so typing these in, I have 43.8, 34.3, and 37.5. Okay, so which of these has the highest probability? Well, it would be product X. Has the highest percentage of people searching and also buying. Okay. All right, so this next one is pretty much the same idea. So I will post the solutions to this as part of the scanned copy of the notes. Homework is posted and you guys can call in during office hours if you have any questions. All right, guys, have a great day.